So next up, we've got Clive Neal. He's going to talk to us about surface missions to understand our moon, science and exploration combined. Clive,
Okay,
have at
thanks
it.
very much. I will have at it. And as the slides come up, uh, okay, that looks weird, but go to the next slide. Thank you. No, you went too far. Go back one. Here we go. This is why I love to do my own slides. But so evolving clips by reconnaissance sample return is is the sort of subtitle to this one. If you go to the next slide, please. We have numerous documents that we can look to. Oh, all my transitions are on. This is a PDF. Okay, that's going to be interesting. Very good. You didn't tell me about that. We have numerous documents we can go to. We can go to the 2007 SCEM report. We can the current decadal that it's about to come defunct. That talks about sample return, and especially from South Pole Aitken Basin, the New Frontiers class mission. But it also looks at the nature of volatiles, recent lunar activity, and the reconstructions of the thermotectonic magmatic evolution of the moon and the impact history through sample return. If you look at the midterm, it actually talks about properly budgeting for sample return. We know that samples are the gift that keep on giving, and so keeping them preserved for future generations allows not only the training of the next generation for analyzing planetary materials, but also in making new scientific discoveries as the technology improves and we can do more sophisticated analyses. Next slide, please. So again, the Lunar Exploration Roadmap that League put together, all those objectives there, not just in the science category, all have robotic sample return as an early stage, and also development of sample return technology has feed-forward implications to other destinations. Next slide, please. The coming a bit more recent with the advancing science of the moon, which was a retrospective on the SCEM report. But those concepts 1 through 7 that were in the original SCEM report could all benefit from sample return, as can the new concept of the origin of the moon. Next slide, please. So we've got a rich sources of justification in terms of science documents. And if we look at the data that we have from orbit, we can put together these maps which show potential locations to actually address some of the science questions that have been put forward. And reconnaissance sample return away from Artemis landings can guide future human exploration. But the other thing that we also have is this sort of exploration and engineering goals of samples as well, which actually require much more sample mass because our simulants, no matter how hard we try, still remain Earth materials, not lunar materials. Next slide, please. We can do targeted sample return. Well, we hope we can. We know that it can be done because it's been done recently by Chang'e 5. And if we look at the sort of breaking down a robotic sample return mission, we can see that we've got to land at the desired location. We've got to gather the sample. We've got to launch back to Earth, and we've got to successfully land back on Earth. Next slide, please. And putting those things together, we can see that there are evolution in sample return missions. So for example, if we land at the desired location, is a static lander sufficient where we just do a grab sample of regolith because we are confident that the materials we need to address the science are going to be incorporated in that particular regolith? Is mobility needed? Do we need a fetch rover? How far does it need to go? And precision landing, how precise do we need to be to make a static lander possible? And these are all questions that need to be looked at when we're starting to evolve the technology needed to do robotic sample return. Next slide, please. Gather the sample, is bulk regolith sufficient? Do we actually need hand samples? We know from Apollo that the hand samples have been preserved, and we've got a wealth of data from those samples. How are we going to transfer from a fetch rover to a sample return capsule? Will we require special storage capabilities? Are we looking at cryogenics? Are we going to be able to return some of the water ice that is in these permanently shadowed craters? And are surface samples sufficient, or do we need a stratigraphy of the regolith? Next slide, please. Launching back to Earth, we know that the Soviets did this. They did a direct to Earth trajectory from launching from the moon, but then the Chang'e 5 lander did a rendezvous with an orbiter and then came back to Earth. Next slide, please. So we've got the science requirements that need to be looked at as an evolving capability in sample return. We've got to land back on Earth. Can we actually, is litho braking permitted? Do we capture it in the atmosphere? Do we parachute it and let it come in as a reasonably soft landing? What's the minimum mass? I suggest 2 kilograms, because we need to be able to preserve this for future generations. We need to be able to go back and test the hypotheses that come out of initial sample return. And again, this all requires cost. It requires development. Next slide, please. So we need to think about the evolution of our CLPS program to sort of have a list of questions. Landing with a static lander to gather regolith and then bring it back to Earth is probably the simplest way of doing it, but not all of the landing sites that are in those maps will actually be able to actually get the right samples with a static lander. Right now, we've got an evolution of CLPS going along from initially disparate payloads, and again, big implications for ConOps. We've got less than 1 lunar day duration, although we've heard some CLPS providers can do better than that. Communications back to Earth, there's some mobility being provided. So this represents a great start. And as I said in the panel, we need to evolve this program into something that is credible, that has boundaries that we can point to, saying that now we really need to do a Discovery or New Frontiers mission, because the capabilities offered by this frequent program will not address the science or exploration goals that we've developed. Next slide, please. So I think this is my final slide, and evolving CLPS. So this is the beginning of the roadmap, Amy, if you like. Again, reconnaissance sample return. I use the term reconnaissance because not all questions are going to be answered by one sample. And again, it's also limited
2 minutes.
compared to, I'm going to be ahead of time, but I'll talk slow. The samples will not be as generous as we would get from human exploration. So these are reconnaissance, and they need to be viewed as such. And we need to be evolving these to more targeted samples with more complicated fetch rovers. Now, is this outside the cost cap of CLPS? Well, then we've got okay, this is actually a Discovery or New Frontiers mission. Mobility over several kilometers. It's important for resource prospecting. It's mapping lunar swirls, so on and so forth. Mobility is enabling. And then surviving and operating during the lunar night, in fact, multiple lunar nights. If that can happen in a CLPS budget, then maybe it can enable a long-lived geophysical network on the moon. The current capabilities cannot, because the capabilities that are being reported by the commercials cannot survive multiple lunar nights. And then we get to CLPS to other destinations, which has already been talked about by the Mars community. But what about CLPS to asteroids? What about the trade space needs to be opened up, and we do need a successful CLPS landing on the moon to be very, very enabling. And with that, I will stop.